Deep Neural Network for Financial Systems and Budgeting, Pradeep K. Suri, author, researcher, and AI/ML architect, DNN and LLM. Conclusion. This map visualizes the interconnected subfields of AI, highlighting key technologies, mathematical foundations, ethical concerns, and practical applications. The structure aligns with how large language models, LLMs, such as GPT, function by integrating multiple AI domains to generate knowledge-based outputs. Deep Neural Network for Financial Systems and Budgeting, Pradeep K. Suri, author, researcher, and AI/ML architect. Break down the Deep Neural Network, DNN, shown in the image and discuss its components in detail. Understanding the image. The image depicts a deep neural network, DNN, architecture, specifically designed for financial systems and budgeting, as indicated by the title. Here's a breakdown of what we can infer from the image. Structure. The network is composed of multiple layers arranged sequentially from left, input, to right, output. This layered structure is a hallmark of neural networks. Nodes/neurons, each layer consists of multiple nodes or neurons, represented by circles. These are the fundamental processing units of the network. Connections/weights, the lines connecting the nodes between layers represent connections. Each connection has an associated weight, which is a crucial parameter learned during training. Input layer, the leftmost layer is the input layer, which receives the initial data for the network. In this case, the inputs would be financial data relevant to budgeting, example income, expenses, past transactions, market trends, etc. Hidden layers, the layers between the input and output layers are the hidden layers. The image shows multiple hidden layers, making it a deep neural network. Hidden layers are where the network learns complex patterns and representations in the data. Output layer, the rightmost layer is the output layer, which produces the network's final result. For a budgeting application, the output could be predicted budget allocations, risk assessments, or financial forecasts. Detailed explanation of DNN components and functionality. 6 neurons, nodes. Core processing unit, at the heart of a DNN is the neuron. It receives inputs, performs a mathematical operation, and produces an output. Activation function, each neuron has an activation function, example sigmoid, ReLU, 10. This function introduces nonlinearity, enabling the network to learn complex relationships. It determines the neuron's output based on the weighted sum of its inputs. 7 connections and weights. Weighted links, connections between neurons have associated weights. These weights are crucial because they determine the strength of the connection and influence the flow of information. Learning through weight adjustment, during the training process, the network learns by adjusting these weights to minimize errors in its predictions. 8 layers. Input layer, receives the raw input data. The number of neurons in this layer corresponds to the number of input features. Hidden layers, these layers are where the magic happens. They learn abstract representations and complex nonlinear relationships in the data. DNNs have multiple hidden layers, allowing them to capture intricate patterns that shallow networks cannot. Output layer, produces the final result or prediction. The number of neurons in this layer depends on the task, example classification, regression. 9 Forward propagation. Data flow, input data is fed forward through the network, layer by layer. Weighted sum and activation, at each neuron, the inputs are multiplied by their corresponding weights, summed, and passed through the activation function. Output generation, this process continues until the output layer produces the network's prediction. 10 Backpropagation. Error calculation, the network's prediction is compared to the actual target value, and the error is calculated. Gradient descent, the error is then propagated backward through the network to adjust the weights. This adjustment is done using optimization algorithms like gradient descent, aiming to minimize the error. Iterative learning, this forward and backward propagation process is repeated many times, epochs, until the network's performance improves and the error is minimized. Why deep neural networks for financial systems and budgeting? DNNs are particularly useful in finance due to their ability to learn complex patterns, Financial data is often complex and nonlinear. DNNs can uncover hidden patterns and relationships that traditional methods might miss. Handle large data sets. Financial institutions have access to vast amounts of data. DNNs can effectively process and learn from these large data sets. Improve prediction accuracy. DNNs have shown superior performance in various financial forecasting tasks, including stock price prediction, risk assessment, and fraud detection. Automate feature engineering. DNNs can automatically learn relevant features from raw data, reducing the need for manual feature engineering. Specific applications in budgeting. Personalized budget recommendations. DNNs can analyze an individual's financial history and provide personalized budget recommendations. Financial forecasting. DNNs can predict future income and expenses, helping individuals and businesses make informed budget decisions. Risk assessment. DNNs can assess the risk associated with different budget scenarios. Anomaly detection. DNNs can identify unusual transactions or budget deviations that may indicate fraud or financial distress. In conclusion, the image represents a deep neural network designed for financial systems and budgeting. DNNs, with their multiple layers and nonlinear activation functions, are powerful tools for learning complex patterns in financial data. They can be applied to various budgeting tasks, including personalized recommendations, forecasting, risk assessment, and anomaly detection. The learning process involves forward propagation of data and backward propagation of errors to adjust the network's weights, ultimately improving its predictive capabilities. 1. AI and its subfields. At the center of the map, artificial intelligence is the broad domain that encompasses multiple specialized areas, such as machine learning, ML, the study of algorithms that allow computers to learn from data. Deep learning, a subset of ML that utilizes neural networks for advanced pattern recognition. Reinforcement learning, RL, a branch of ML focused on agent-based learning in an environment to maximize rewards. 2. Deep learning and neural networks. Neural networks are the backbone of deep learning and are categorized into convolutional neural networks, CNNs, used in image recognition and computer vision. Recurrent neural networks, RNNs, used for sequential tasks like speech recognition and time series forecasting. Transformers, example BERT, GPT, used in natural language processing, NLP. Deep learning enables applications in cognitive computing, AI mimicking human cognitive processes. Robotics, AI-powered robots with human-like decision-making. Virtualization and functional programming, AI models optimized for distributed computing. 3. AI governance and ethics. AI governance covers regulatory frameworks and ethical concerns in AI applications. Ethics in AI addresses bias in AI models, fairness and accountability, transparency in decision-making, privacy concerns in data usage. Predictive analytics involves AI-driven decision-making models for various industries, including finance, healthcare, and cybersecurity. 4. Mathematics and AI foundations. Mathematics plays a critical role in AI models, involving linear algebra, used in tensor operations for ML models. Graph theory, for network analysis and AI model structures. Probability and statistics, for uncertainty modeling in AI. Game theory and decision theory, for strategic AI applications. Combinatorics and discrete mathematics are fundamental in algorithm design. 5. Applications in AI. Computer vision, AI interpreting visual data. Natural language processing, NLP, AI understanding and generating human language. Reinforcement learning, used in game AI, example AlphaGo. Robotics, example self-learning robotic systems. Explanation of the financial prediction line chart. Overview. The line chart visualizes financial predictions for various financial metrics. The x-axis represents different financial metrics. The y-axis represents predicted values in millions of INR. The cyan line connects the predicted values for each metric. The red markers indicate the exact predicted values. Key insights. 1. Fluctuations in financial predictions. Some metrics have high predictions, while others are significantly lower. The trend shows sharp peaks and valleys, indicating variations in financial performance. Too high predictions, peaks. Metrics like working capital, loan repayment ability, and dividend payout estimation have high values, indicating strong financial expectations. 3 low predictions, valleys. Market risk analysis and inventory turnover show low predictions, suggesting potential risks or inefficiencies. 4 patterns and trends. There is a noticeable upward trend in some sections, implying potential financial growth. Some metrics fluctuate dramatically, which may indicate uncertainty or varying financial conditions. 5 customization applied. Thicker line, 2.5 thickness, for better visibility. Black background with white text for a high contrast look. Grid lines to help analyze values more precisely. Conclusion. This chart helps financial analysts and decision makers understand trends, risks, and opportunities. By analyzing peaks and troughs, businesses can optimize budgets, control expenses, and predict profitability effectively. Financial Prediction Report Explanation. The Financial Prediction Report provides insights into key financial metrics for an organization, expressed in millions of INR. These metrics help in forecasting financial health, optimizing strategies, and managing risk. Below. 1. Revenue growth percent, 377.73 MINR. Measures the expected increase in revenue over a period. Positive growth indicates a healthy expansion of the company's income. 2. Expense reduction percent, 495.41 MINR. Forecasted reduction in overall business expenses. Higher value implies effective cost-cutting strategies. 3. Cash flow prediction, 510.09 MINR. Estimates the expected cash inflows and outflows. Helps in ensuring liquidity and operational sustainability. 4. Investment forecast, 303.94 MINR. Predicts the company's capital expenditure and potential return on investments. Important for strategic planning and future growth. 5. Profit margin percent, 311.50 MINR. Estimated percentage of revenue converted into profit. A key indicator of business profitability. 6. Market risk analysis, 322.44 MINR. Assesses potential market-related risks, example economic downturns, competition. Helps in mitigating financial losses. 7. Budget allocation efficiency, 500.98 MINR. Measures how effectively budgets are allocated across departments. Ensures optimal resource utilization. 8. Operational cost percent, 546.99 MINR. Predicts business operating expenses as a percentage of revenue. Lower values are preferred for efficiency. 9. Debt to equity ratio, 510.32 MINR. Compares the company's debt against shareholder equity. Indicates financial leverage and risk level. 10. Working capital, 561.64 MINR. Measures short-term liquidity. Higher working capital ensures smooth operations. 11. Sales forecast, 308.02 MINR. Predicts future sales revenue. Essential for inventory management and growth planning. 12. Customer acquisition cost, CAC, 416.99 MINR. Measures the cost to acquire a new customer. Lower values indicate cost-efficient marketing strategies. 13. ROI on marketing, 427.84 MINR. Forecasts return on marketing investments. Higher values mean effective marketing campaigns. 14. Inventory turnover, 558.36 MINR. Measures how efficiently inventory is managed and sold. A high value indicates good sales performance and inventory management. 15. Supply chain optimization, 597.13 MINR. Assesses cost savings and efficiency in the supply chain. Helps in reducing logistics and procurement costs. 16. Production cost analysis, 357.30 MINR. Predicts manufacturing expenses. Crucial for pricing and profitability assessment. 17 Overhead costs, 589.85 MINR. Estimates non-production related expenses. Helps in cost reduction and budgeting. 18 Tax liability estimation, 374.68 MINR. Predicts the expected tax burden for the company. Affects net profit and cash flow. 19 Net profit prediction, 471.19 MINR. Forecasts total earnings after expenses and taxes. A key measure of overall business success. 20 Annual financial health score, 326.17 MINR. Aggregated score evaluating the overall financial stability. Higher scores indicate strong financial health. 21 Revenue per employee, 432.67 MINR. Measures productivity by evaluating revenue generated per employee. Higher values reflect efficient workforce utilization. 22 Cost per customer, 366.76 MINR. Measures total expenses divided by the number of customers. Helps in pricing strategies and profitability. 23 Technology investment impact, 534.82 MINR. Predicts the ROI from technology-related investments. Helps in digital transformation planning. 24 Loan repayment ability, 502.40 MINR. Forecasts the company's ability to repay debts. Critical for maintaining creditworthiness. 25 Dividend payout estimation, 435.71 MINR. Predicts the amount distributed to shareholders. Important for investor confidence and stock valuation. Key takeaways. 1 High working capital, 561.64 M, and revenue growth, 377.73 M, suggests strong liquidity and expansion potential. 2 Optimized cost management, expense reduction, 495.41 M, operational cost, 546.99 M, overhead costs, 589.85 M, improves profitability. 3 Market risk analysis, 322.44 M, and loan repayment ability, 502.40 M, help in risk management. 4 Supply chain optimization, 597.13 M, and inventory turnover, 558.36 M, indicate efficiency in operations. 5 Strong net profit, 471.19 M, and ROI on marketing, 427.84 M, show profitability potential. Thank you.